Lesson 5.4, Factor and Solve Polynomial Equations, under the subheading, Factoring the Sum or Difference of Two Cubes. The first thing we're going to do is look at a pattern, and this pattern may be a little bit confusing until we actually put some numbers to it. But here's the pattern written with all variables. If we have a cubed, and we're adding it to b cubed, I know that the factored form of this will be a plus b, a squared minus ab plus b squared. That's the pattern. If we look at this in terms of numbers, we'll say we have 8x cubed plus 27. Okay? To determine whether or not we can use this pattern, one or two things has to be true. First of all, both of these terms have to be perfect cubes. Now we've talked about perfect squares. We know the perfect squares pretty much by heart. But perfect cubed is the same concept, except you have to multiply it by itself 3 times. So in this case, x cubed is definitely a perfect cube because it's x times x times x. 8 is also a perfect cube because it's 2 times 2 times 2. 27 is a perfect cube because it's 3 times 3 times 3. There is a cube root function on your calculator, so you can check any number that you wish to see whether or not it is a perfect cube using your graphing calculator. Once we establish that both terms are perfect cubes, we just have to make sure we're looking at a sum or a difference. Now, unlike the difference of two squares where you could only do it if it was a difference, you can do the sum or difference of two cubes. So if they are both terms are cubes, you know you can go ahead with one of the two patterns. Once we've determined this, we need to designate A and B. A is always going to be the cube root of your first term. So the cube root of 8x cubed is 2x. B is going to be the cube root of your second term, which in this case is 27. Cube root of that would be 3. What you have to memorize for the pattern is this: A, B. A squared, so you got to square all of A, which would give you 4x squared. The middle term then is A times B, which would give you 6x, and B squared, which would give you 9. If you can remember A, B, A squared, AB, B squared, you can figure out the signs by the acronym SOAP. SOAP will stand for same, opposite, always, positive. Okay? So in this case, SOAP, the same sign as the problem, opposite, always, positive. Okay? That comes in handy because now whether it's a sum or a difference, you are always going to get your signs right, because the only difference between a sum and a difference, okay, the only difference between those two things is the way your signs go. In other words, if we have a cubed minus b cubed, it's still going to be ab, a squared, ab, b squared, but now when I do SOAP, same, opposite, always positive. The only difference to note, whether it's a difference or a sum, is the sign. But if you remember SOAP, same, opposite, always positive, you don't have to memorize two separate formulas. Okay? This all can be a little confusing, but let's try one or two examples here. Number 1. Let's look at x cubed plus 125. When I look at this, I notice there's two terms. I also notice that there's no common monomial factor, so I can't pull anything out. The next thing I'm aware of is that it's an addition sign, so it can't be the difference of two squares. So the only thing that is left for me to do would be factor if they are both perfect cubes. X cubed I know is a perfect cube. 125, this is my first time dealing with perfect cubes, I'm not sure, so I'm going to check it on my graphing calculator. Okay. When I do cube root 125 into my graphing calculator, I notice that it is a perfect cube because my answer is 5. Once I have that, I can say that A is going to be X. Remember, A is always the cube root of your first term. B is going to be 5, the cube root of my second term. At this point, I don't really care whether it's a sum or difference because I know when I use the acronym SOAP, that's going to take care of it. I just have to worry about placing the A's and B's. It always goes A, B, A squared, A times B, B squared. And now I can place my signs according to SOAP. Same, which means addition. Opposite, always positive. Once I use this pattern, the perfect cube pattern, okay, I know I'm done. I don't have to look to see if I can go any further. You might glance at this and say, oh, well, that's a quadratic trinomial. Maybe I can factor that a little bit further. You're never going to be able to factor that second trinomial any further when you use the sum of two cubes. So I know from this point I'm done, which is the nice part about using the pattern because I use it once and then I know I'm done. Alright, let's try one more example here. Let's say we have 16z to the 5th minus 250 z squared. Alright, looking at this, I see it as a binomial. Okay, first thing I always look to do is see if I can factor out a common monomial factor, which in this case I absolutely can. Between my coefficients, I know I can factor out a 2. Between my variables, I can factor out a z squared. That will leave me with 8z cubed minus 125 inside parentheses. Once I've factored out the common monomial term, I can look inside the set of parentheses and see if I can continue. It's two terms, so the only possible thing I can do would be to check for one of the two patterns. Is it the difference of two squares, which in this case I can see is not going to work because neither of those terms are perfect squares. So my only other option would be perfect cubes. 8z cubed is a perfect cube, so is 125. When I go forward from here, a is the cube root of my first term. The cube root of 8z cubed is 2z. b is the cube root of my second term, 125, which when I put that into my calculator, I know the cube root of 125 is 5. Don't worry about the minus sign in there. Some people try and attach a negative 5 to b. We're ignoring all signs because I know SOAP will take care of it. So I'm strictly looking at 8z cubed and 125. I don't care about that minus sign for right now. So I have a is 2z, I have b is 5. I'm going to still write that 2z squared out in front, and then I will have a, b. I'm going to squeeze this in down here. A squared, which will be 4z squared, a times b, 10z, and b squared, which is 25. Now I apply SOAP, which would be same, so minus, opposite, always positive. So my final answer here is all of this. 2z squared times the quantity 2z minus 5 times the quantity 4z squared plus 10z plus 25.